Hey kids, it's Mr. D. I'm here to talk to you about the seasons. I'm just going to explain to you, using this awesome simulator from the University of Nebraska, how we get our seasons. Before we do that, I want to talk to you quickly about hemispheres, which I think you've already studied. But the world is broken up into hemispheres, meaning it's broken into sections. We live in the northern hemisphere, okay? And we are also in the western hemisphere. So we are in the northwestern hemisphere. Okay? So northern and western. And what hemisphere you're in, northern or southern, really determines your seasons. Okay? And I'll show you in the simulator, but when it's summer in the northern hemisphere, it's winter in the southern hemisphere. Okay? So the northern and the southern hemispheres really determine what season you're having when. So here's our simulator, and this simulator is really, really awesome. What it does is it shows you the orbit of the Earth around the Sun. It takes 365 days, or 1 year, and it also shows you the angle of the rays. And it's really the angle of the rays that determines the season. So think about it if you're spraying a garden hose on somebody. If you're spraying a garden hose on somebody and you're aiming directly at them, it's going to make a huge splash. But if you're hitting them at an angle, it's going to bounce off. Okay, it's not going to have as big of an impact. The sun's rays work the exact same way. When they're hitting you directly on, it's warmer. And when they're hitting you from an angle, it's colder. Now, believe it or not, there are times when the Earth is further away from the Sun, when it's here and here, than other times here and here. And I wonder, and I think we'll know by the end of this discussion, if closeness to the Sun has anything to do with the seasons. So, here's Connecticut, where we live. It's in the northern hemisphere, so I'm going to move our little marker, up to approximately where Connecticut is. Okay? Now look at the angles down here. Since the angles are not directly hitting the ground, it's colder. And right now our marker is February 13th. See? February 13th. Okay? Now watch what happens as we start the animation. Okay? We're starting in February. Let's go to end of April. See what happens. Watch the sun's rays. See how the sun's rays? All of a sudden in April, the sun's rays are much more direct, aren't they? Much more direct on us. So it's warming up. Okay? That means it's going from winter to spring. And now let's go right into July. Right into the hottest of July. Look at the sun's rays. They're directly on us almost. See them up here? But notice how far the Earth is from the sun. At its farthest point, it's the warmest. Okay, do you see that? Now let's continue on. Now we're into fall, and it's starting to cool off. Notice the sun's rays right here. Okay? See our position? The sun's rays are not directly on us anymore. And then we get into winter. And look, in winter, we're really not getting any direct sunlight. It's at a significant angle. And again, we're farthest away from the sun. But if I take this Earth and I drag it back to where it's closest, well, that's September. That's not the hottest time of the year. And if I go back here, where it's farthest, that's the middle of summer. That's June 30th. And if I go over here, it's winter. So it appears that when the Earth is the furthest from the sun, it's either the coldest for the northern hemisphere or the warmest. Isn't that interesting? So now let's continue on and get us back to February. So now we're in February, and now the Earth is the sunlight's starting to get more and more direct, more and more direct. And we're back to February 13th, where we are today. And you can see that the sun's rays are not directly hitting us. So, the other thing that's interesting is watch. In the middle of winter, let's go to the winter, okay, where it's the coldest. Let me see. We'll say right here. I can't seem to get it exactly right. Look at the angle of the sun in the northern hemisphere. Now watch. I'm going to take our marker and I'm going to move him to the southern hemisphere. Look at that. It's summer in the southern hemisphere. So in the northern hemisphere it's winter, southern hemisphere it's summer. Now one other thing to look at that's really interesting is for people that live on the equator, there's not a lot of fluctuation. There's not a lot of seasons. The seasons really occur in the northern and southern hemispheres, closer to the poles. So watch this. Watch as I spin this around. Watch the angles down here. Just watch the angles down here. They don't really change that much, do they? They change a little, but not a lot. It's warm all year round. That's why people go to Florida and Hawaii and Mexico in the winter, because it's always warm there. One other thing I want you to notice is that when the sun, the side that is facing the sun is daytime, and the side that's not facing the sun is nighttime. Okay? It's very interesting. Now, keep this in mind, and it all has to do with the tilt, which we've talked about before, but just keep in mind that as the Earth orbits the sun, okay, as the Earth orbits the sun's rays are more direct and less direct depending on where you are on the Earth, and that determines the seasons. Okay? All right, great job. Feel free to check this out. Bye.